Welcome everybody. We're going to have a webinar today talking about robotics and structural steel fabrication. We've seen a huge increase in structural steel fabrication using robotics and trying to solve a lot of problems in the industry. And I really have some world-leading authorities with me here today. My name's Doug Evans. I'm the Vice President of Sales in North America at SDS2. I have Dr. Andreas Hofer with Zeman. I have Michael Flagg with Lincoln Electric and Rick Bosca with Lincoln Electric. So there's our lineup today. Excited to get going and have a discussion on this. A little bit about SDS2. We were founded in 1981 as a steel detailing software. We're really the leading provider of steel detailing when it looks at automating the process from design all the way through construction. In the mid 20s, we were acquired by Nemetschek out of Munich, and just this year, we are now part of Allplan, which is again showing our dedication to the design build from the start to the end of the process. So now I'd like to introduce Lincoln Electric.
So Lincoln Electric is the world leader in the design, development, and manufacture of arc welding products, plasma and oxy-fuel cutting equipment, and automated cutting, joining, and assembly systems. Founded in 1895 by John and James Lincoln, the Cleveland, Ohio headquartered company has 55 manufacturing locations in 18 countries and a worldwide network of distributors and sales offices covering more than 160 countries. Our Higher Standard 2025 strategy is based around understanding our customers' needs, improving their ability to make their products better, safer, and easier, improving our quality and costs, and developing our employees' opportunity to learn and grow, all while improving safety and sustainability. Lincoln Electric understands the increased labor challenges our customers are facing. By striving for operational excellence using automation, we can help them capture growth and profitability. With a product line that spans from manual cutting, welding, and safety products to fully automated production lines for every industry, Lincoln Electric has innovative solutions that meet our customer needs for quality, safety, and productivity wherever they are needed.
Thank you for that. Now let's move on to PythonX.
So PythonX is a market leader in robotic plasma cutting with 3 cutting offerings in our solution suite. Two are in the 3D cutting space with the PythonX structural and the PythonX SVG. And we have one offering in the 2D space, which is PythonX plate.
Thanks again, and let's go to Zeman now.
All right, my turn. My name is Andreas Hofer. I'm the General Manager of Zeman Bauelemente. We have been founded in 1965 by Mr. Zeman, who is also my father-in-law, and we are based out of Austria, Vienna. There is the sales office and the manufacturing facility located in Scheifling, which is in the middle of Austria. We got acquired by Lincoln Electric in 2021, and we believe that we are the market leader in fully automated assembly and welding solutions. And we have already built a lot of different machines and sold these machines very successfully to the North American market.
So thank you for that introduction. And we have worked with these companies for a long time. We have customers that use both our technology and their technology, and we've learned a lot through that process. And part of this webinar is just to share some of the things we've learned. And we've seen huge impacts in the productivity and the quality of projects with our customers, and just want to share a little bit of that. So with that, really, what problems or challenges in the structural steel industry causes a fabricator? He's got a lot of things he can spend his money on. So I'll kind of throw out to you, why would they choose automated equipment and robotics versus putting their money in other parts of their shop or their employees? Go ahead.
Yeah, so I'll start with basically saying, there's a lot of challenges in the fabrication industry at the best of times, but certainly the age of the labor pool, the fact that there's not a lot of skilled labor coming into the labor pool, is really challenging fabricators in terms of their throughput and also the consistency of the work that they're putting through the shop. So robotics addresses that. You're going to get a consistent cut quality. You're going to get a consistent throughput, regardless of the product and regardless of the complexity of the cut that's required. Oftentimes we see in shops, especially the smaller shops, where there's zero automation being used. They're still using paper drawings. They're still transferring those paper drawings by hand, using tape measures and squares onto structural steel sections, and then torch cutting those profiles. That is fraught with danger from the standpoint of shop errors or drawing misinterpretation, or just trying to figure out what the draftsman's intention is with the drawing that he's created. The other thing is, because the labor pool is shrinking and the talent is shrinking, you're losing a lot of fabricators and fitters that are able to do very, very complex layouts on beams. And what that does, in fact, is then force the fabricator to do simpler jobs. And what we're finding now is you're seeing more fabricators doing the box type stores and fewer fabricators doing the more complex projects. So what that's doing, in fact, is driving down the price where there's more competition to win those simpler projects. So automation does a lot of things for you. It simplifies your process. It gives you a consistent throughput and consistent quality of work, but it also expands your ability to do more complex work without adding very expensive labor. So in a nutshell, that's where I think robotics really comes into play. The last thing I'd say to you too is that, if we're all have the same drill lines and the same saws, what makes us really differentiates us from each other and what we can do for our prospective clients. When you add automation to your facility, you really differentiate yourself. You really start to control your costs. You become much more profitable, and you're able to do things that your competitors potentially can't do. So what we've seen historically is the people that acquire the PythonX equipment certainly differentiate themselves in the market. They make themselves much more competitive, and they're able to take on much more complex projects.
Andreas, Mike, do you have anything to add to that on that topic?
If I may say, of course, I simply underline what Rick said, and we are definitely aligned because we know each other and we know the automation business and we know our customers quite well. It's the flexibility what we are offering to them as well, because if there is a huge project, they have to ramp up the workforces, what they can't get on the market, so availability of qualified workers, it's really a big issue. If you have a machine, a robotic machine, you simply use the machine and you can flatten this typical production bell curve. So that is one of the major advantages. In the past, structural steel, we lived in a 3D world, let's say dirty, difficult, and dangerous. Right now, we live in the 3D, three-dimensional world, and we take the data from SDS2, download it to our machines, and there we start. It's repetitive. It's not so much repetitive work. It's a lot by lot production. Don't get me wrong. It's not like automotive industry where you teach the robot and they are always doing the same move. We have different beams in our industry, and our machine, they can do a lot by lot, difficult and single beams simply by downloading the 3D data. So yeah, there are challenges, and I believe the robotic system is kicking in, and it's not a question if it comes to all the fabricators, it's only a question when.
And I'll follow up on the 3D modeling side. A trend we have certainly seen is model-based estimating workflows. So people are trying to project and predict their labor costs better. So having that automation is, as you said, Rick, the more predictability, consistent throughput allows them to give a value to holes and welds and cuts based off time, and it's more consistent. So that model-based estimating workflows become really popular with those manufacturers and fabricators that have you guys' equipment, because it's more predictable and they can then cost it better instead of just adding a percentage and hoping they're right. So it certainly helped that. So with all those benefits, then what are some of the major, as people are listening to this, what are some of the major reasons why people say, you know, maybe this isn't for me, or maybe I shouldn't do that? So you've outlined a lot of the value in why we should. What are some of the things that are holding people back then?
You know, I'll start. I think there's a lot of perception out there that going to robotics, it's complicated. The operators can't understand the programming. It's difficult. And I think the robotic companies have gone a long way to try to simplify everything. If you start looking at the teach pendants that are out these days compared to, 10 years ago, they're now based off of tablets. They're similar to computer objects that people use on a day-to-day basis. So they're a lot simpler for the operators to use. They're not those complicated pieces of equipment. They're also a lot safer, particularly on my side. If you look at some of the collaborative robots that are out there, you don't have to have all that safety fencing, mats, light curtains around them. Now the sensors are built into the arm, so you can work right next to a robot. You don't have to worry about your operator potentially getting injured. So it really frees up, to Andreas's point, it really frees you up on the flexibility side. You can move these into locations that you just couldn't put a regular robot in the past. So they're much more flexible, they're safer, and they're simpler to use.
Yeah, I would certainly echo that from the technology side. On the software side, 25 years ago, when I would go into a fabrication office that had some automated equipment, there was that one person that knew it. And only one person that knew it, and they couldn't lose them, and it was really hard to train them. Now, getting NC operators is a little bit easier, and it goes towards, as you said, we're all dealing with a shortage of labor. You don't lose them; you're just using them in better and different ways. Certainly, when you see people implement robotics, and so that's been great. So now that I've overcome those hurdles, hey, I think this automation is something I should do. I've got people that I think I can train because the technology is easier. How do I know what to buy? I look at my work process and I look at, here's the operations. I'm in the industrial fabrication or commercial fabrication, or I do canopies, or maybe I'm doing pipe racks. How do I know how do I look at my shop, see where I spend man hours, and know what equipment will move my needle and help me better as a fabricator? How do I evaluate that? What's a good way?
I think, there's a couple of things here, right? The unique thing about Lincoln Electric is that when you acquire Lincoln Electric equipment, we're the only provider out there that's truly a single source, right? When you look at the cutting aspect of the business, You look at the assembly aspect of the business, and then finally the welding aspect of the business. We're the only company that comes to the table with all those solutions under one roof. So from that perspective, having a partnership with Lincoln Electric is certainly a unique situation, because from the time the material comes in to the time it leaves the door, you're dealing with one company. But really what it comes down to from my perspective is the competitive nature of the business. There was a time when people stayed within a certain area. Now they're working throughout North America. So when you're looking at your business, you've got to decide, where the bottleneck is and where is the best potential for you to reduce your costs, reduce your material handling. So both Zeman and the PythonX lines both address those situations. On the Zeman side of things, you need a little more square footage in your building, and you need a little more ceiling height. But at the end of the day, that product is unsurpassed in the industry in terms of what it can do for a business. But I think at the end of the day, you've got to look at your business. You've got to decide where your bottleneck is, where your weaknesses are, and you got to do that realistically. And then you have to decide where you want to get to. Right? What's your next step? Where do you want to grow to? On the PythonX side of things, people are often concerned about the cost or the ROI or support, or I don't have the tonnage, and really that's not really the way to look at it. You've got to, what this solution is it addresses your man hours. So if you're producing a product or a job that is somewhere in the neighborhood of 30 man hours per ton, and you can save 50% of that by buying a PythonX, that addresses a significant amount of your issues and your costs, right? From my perspective, cutting, I think, is a very important part of the process. It's very, very manual. Downstream of that is then the Zeman solution.
So,
yep.
Can you give me an example, or sitting down with a fabricator and showing him where his bottleneck is? How do you do that? I mean, of course, he's got ideas. Maybe you can look at his payroll and say, hey, all my welders I'm paying him this much. But how do you sit down and help him find out where his bottlenecks are?
I think Andreas and I probably do the same thing, or I know we do. We will present our solutions, and then we'll ask the client for sample drawings of material that's actually going through his shop today. And why that's important is because we are going to give them cycle times based on that particular production run. He already knows what his estimated time is. He's going to know, if he doesn't already know, what his actual time is per part. We're going to come to the table and now say, you're going to save this many man hours in producing the part. And that is where the light goes on for most clients. They understand that they can now create their own ROI model. So from my perspective, and Andreas, I know yours is a little bit different, but historically, there's no question this equipment is expensive, but when somebody's paying $750,000 for a piece of equipment, but they're realizing an ROI in 18 to 24 months, that's pretty outstanding. And then you compound that with the fact that that piece of equipment, that PythonX piece of equipment is going to be in your shop for 15 plus years. That's an outstanding return on investment.
Anything to add?
Let me add, sorry, that we are exactly doing the same. So we ask our customers for some typical drawings, and we do the time studies based on different models which we are offering to the market. And the comparison is there. I mean, they understand what the saving is by using the Python machine, by using the assembly and the weld out unit. And just imagine one plate we are handling up to 440 pounds takes you 1.5 minutes. So just imagine if you have one plate and you have to handle that in weight of 440 pounds, you at least need 2 guys, a pillar crane, and in our case, the magnetic robot picks it up, adds it on, TAC welding, it's done. 1.5 minutes. So that is the saving, that is convincing. And of course, there are testimonials on the market. So I believe the hard time is already over for Zeman, because we have more than 30 machines out on the market, on the North American market. So if there is a customer being interested, he pays a visit to one of our clients, and he will ask them what kind of saving, what is the profitability. And then one customer will tell him, hey, we take on Amazon projects. And in the past, we have done 2 columns a day during one shift. And right now we do 12 columns on the Zeman machine. So that makes you save. That gives you, let's say, the safety that this investment is really a good investment.
I think, Andres, I think you hit on a really good point there. Material handling. I was in the business for many years, and I didn't realize, in my career until it was finally brought to my attention, how many times a beam is touched. From the time it is delivered to the time it's moved into the shop to the time it goes through a beam line and a saw, and then throughout the various stages within the shop right out to the paint bay. When you acquire automation, one of the things you're trying to accomplish is the tenets of lean manufacturing. You're trying to do as much possible to that particular piece of steel without touching it or moving it, right? So in both our cases, if you imagine a shop that has a PythonX, it has a PythonX plate machine, and it has a Zeman, a steel beam assembler system, you're loading a beam onto the PythonX. It's producing a beam within, let's just say for the sake of argument, 5 minutes. All the cutting is done. That beam is then going to the Zeman SBA system. In the meantime, a PythonX plate machine is cutting the plate, and then all of that material is coming to the Zeman and then being assembled. So you've touched the beam potentially once. If all of these systems are integrated together. Andreas and his team and myself are working on several greenfield projects right now where clients are trying to build the smart factory and integrate our systems later this year. So that's really the goal, right? You're trying to be as efficient as possible. You're trying to take on the tenets of lean manufacturing. You're trying to reduce the amount of material handling. That in effect also reduces the chances of injuries as well, whether they're back injuries or things that we often see in fabrication facilities. So all of these benefits just come together and help to bolster the bottom line and increase your bottom line and increase your profits.
Certainly. And hundreds, if not thousands of shops I visited, the material handling is certainly the thing that is the differentiator between fabricators, how much people really understand how much they touch that. So
yep, absolutely.
Getting to the next point. So a lot of times when they buy our technology, they're buying your technology, they're in a position where they've got a lot of projects. They've got this big project in company history, and I've got to buy some software. I've got to buy some some machines to get it out to be productive. And they feel like they've got some capital. Which is a hard position to put our technologies in. But saying that, what's some advice that you could give to fabricators to prepare for implementing to minimize disruption? So what can they do, depending on, I know each equipment's different, but what can they do to minimize the disruption and get that thing producing the ROIs that you've talked about? Can you speak to that a little bit? How do I now that I've made the decision, this is a good idea, how do I minimize the disruption to get those productivities quick?
So from the PythonX side of things, as soon as we receive an order, project management is assigned to that specific client. That individual becomes the point of contact for the client, and we go through a series of layout drawings to confirm that the system that is quoted meets the client's needs. At times, there are changes that are made throughout that process because the client wants longer in-feed, out-feed, cross-transfers, whatever the case may be. But at the end of the day, we provide a build drawing that the client signs off on. We coordinate very closely from a project management standpoint and the end user in terms of timing. So we coordinate dates. We know the client knows exactly when we're coming in. They know what work they have to do at their end if there happens to be some electrical upgrades or whatever the case has to be implemented on site. But from a PythonX perspective, it takes 5 days to install a piece of equipment, and then the following week we're doing the training on the system. I know it's a little bit, Andreas's equipment is much more complex, but I'm pretty confident that his answer is going to be very, very similar. The coordination between ourselves and the client is extremely important, and that dialogue is extremely important to make sure that everything is in place for when the machine shows up, so that we can get the client up and running. Really good installations go as quickly as 3 days, but typically they're 5 days. Andreas, you can speak to your side.
Yeah, that's. Thank you very much, Rick. I think we have a little bit more time to align ourselves with the customers. We are not yet in the position to deliver the machine after 4 weeks of receipt of down payment, so we need a bit more time. But general coming back to your question, Doug, it's a disruptive technology what we are offering. So that means there has to be some consideration how to implement that properly to the plant. And we have like a 6 to 8 months time, let's say, to discuss everything, harmonize the training, invite the people to Austria, make them feel and touch and understand our technology, do some trial runs on the machine, see how the robotic systems work. So they come to Austria, feel comfortable working on the machine. Then we have the training at site. So I believe when we leave the customer, they feel really comfortable working on the machine. When the commissioning is already done on 1, 2, 3 projects, so that means we are only providing an on-floor guidance of the operation of the machine. And having said that, the service is excellent at Python and also Zeman machines. So we have a 24/5 service. So that means we are really throughout the whole day and night available for any issue. Remotely, we can sort out 99% of all the issues. This is a major item and a major topic, let's say, for Zeman to support our customers well.
And I think that goes with our technology as well, is it really takes a dedication and commitment. It's not a plan B. There is no plan B. This is what we're doing. We all believe it's the right path and commit to it versus kind of dipping into it and saying, well, we'll do a little bit of the project here and a little bit there and kind of run in tandem. I think it's one of those commitment things that we've seen. So knowing that, and you've kind of addressed this a little bit, but what are some of the returns, assuming that commitment? This is something we're going to do, we're all in, when we're going to get to training. You've talked about some of the returns. What are people seeing with the different technologies and adapting it? So how long does it really take them to start paying? And you've kind of addressed that a little bit.
Andreas, you want to go first, or you want me to go?
I mean, the return, of course, it's always different with any kind of different models of the machine, I believe. And I don't want to talk about the return on investment because it's so different at different fabrication shops. But what I see is the indirect profitability as well, because having such a machine and such a technology integrated in your plant is changing the mindset of the workers. It's changing the mindset of your clients. Some of our clients, they invite their end clients, let's say, to see the robotic systems working. And that has an indirect profitability as return on investment as well, because they feel that this is a forward-looking, leapfrogging customer and which is a valuable partner for any different project. So don't ask me too much about the return on investment, which is there after 2 or 3 years, let's say, on the Zeman investments. But there's a lot more than that. It's not only counted by dollars, let's say. It's to show off to your clients what you're willing to do. You're forward-looking, and you have youngsters working on the machine. Robotic systems play on a joystick to run your factory, and this is the future. Nobody can avoid that.
Yeah, I'm gonna echo that, Andreas. I mean, I've been in the structural steel business and structural steel related businesses my entire life, and I've done major projects and skyscrapers in Toronto and stadiums in North America. You know, nobody's ever given me a hug after finishing a project like that. But I can tell you that, you know, our typical client is a small little fabricator, generally a husband and wife team, or husbands and wives, investing their money into a business. When I go to a trade show, inevitably these clients that have bought the year before, it's very gratifying to have these conversations and listen to their success stories. So much, as much as we believe in the product, getting that feedback is like something I've never experienced in my career. So from a personal perspective, it's a very, very gratifying to see people successful with this machine. That's on the small, mom and pop type operation, owner operator side of things. On the other side of things, I mean, we have clients that have purchased a machine and seen their business grow, and they now have 4 machines, right? Either within the single shop or spread out within the Eastern Seaboard or Western part of the country. So there's a lot of ways to measure success, and we measure it both ways. But as I said, it's a very unique offering when you're affecting people at that level with this kind of technology, and they're seeing that the kind of benefits that we're talking about.
Yeah, and certainly structural steel is, and just go ahead, Mike.
Yeah, it's similar even with the smaller systems. I mean, if you're looking at simple robots or even simple automation, it's those intangibles that you don't think about. You think at first when you're going to invest about the productivity gains that you're going to get, but really making a safer environment for your operators, keeping higher uptime, less fatigue for your operators, those kind of intangibles for your employees, which is going to lead to longer retention for your employees. Those are really the intangibles that you see at the end of the projects that you really weren't looking for when you invested in this technology.
Yeah, and I agree with Andreas. There's so many more reasons than just ROI, production on cutting a beam. Getting from, like we said, the structural steel industry is something we need to continue to recruit and attract workers, both from detailers to shop people. And I think this technology is more exciting, certainly for them. Talking about the model-based workflow, the estimating, that's real powerful where they can get more consistent results and be closer with their bids. And so there's just a lot of return by integrating the technology. And speaking of which, so how has, we're a software provider of 3D modeling technology. How have you seen that evolve over the years, and how has that helped you guys in your work? We spend a lot of time every year, working with automated equipment and programming things, slightly different so that it works. So how have you seen that change in your time with automated equipment? Those integrations.
What I've seen is the software has made it a lot easier for the welding companies to really look at it and say, what can I do? What can I implement? That sort of thing. So when I look at your software and I see a column to a base plate, I now have the ability to change joint designs. I look at that and say, can I automate it, or no, this is going to stay as a semi-automatic operation. So it really helps when the companies are deciding what processes they're going to use, what consumables they're going to use. They can really get down and look at those welds and make a decision on how much they want to automate, how much they want to leave traditionally the way they've been doing it. And it makes it easier for us as suppliers. When we ask the questions, is it seismic, non-seismic, that sort of thing, we can actually visualize and see what's going on through the software and make the right recommendations for the products to do the job.
Yeah, and I'd add to that you look at early days, we're kind of doing our thing over here. You guys are doing your thing over there, as well as some of the other providers, and the client was sort of in the middle of all of that. But today, it's truly a partnership, right? Between SDS2 and the Lincoln offerings, but also more importantly, the client, right? The client's the one that's giving us the feedback to yourselves and to ourselves, and we're the ones that are working together to bring the product and the offerings to the client's expectations, which are always changing. There's always new demands, right? So I would say the strength of the partnership is certainly everybody's rowing the boat in the same direction, as they say now, right?
Yeah. And what I've seen phenomenal impact where even in a design decision, so they're looking at manufacturing capability, what machines they have and what throughput they have to make decisions on connections. Say, hey, if we change the connection, we could get this much more throughput because of this equipment or investment they've made. Now those decisions 20 years ago weren't even considered because they didn't know. But now you have so much more automation that it's predictable and consistent. And so,
well, and I would say 20 years ago there was no option other than the standard drill and saw. That was it, and everything else was done by hand, right? But to your point now, and I guess that goes back to the point I made before too. I mean, if you don't have the talent on your shop floor, there's certain projects you're just not going to take on, right? But with the automation and the technology and the modeling software that exists today, as long as you've got the technology in your shop, there is nothing preventing you from taking on very complex work other than perhaps the lifting capacity in your shop.
So speaking to that, and we have a lot of fabricators obviously in our listening audience. Some of the hurdles over the past have been, well, steel fabrication isn't manufacturing. It's got different challenges. It has mill tolerances. It has different buildings. So I'm not building a consistent automobile. And so what is some of the technology? We talked about seam track. Maybe you can go a little bit deeper in some of the technology that you guys are doing that allows this process, both from how I design my shop and workflow to technology on your machines that allow it to become more manufacturing.
Andreas, you can address that on the Zeman side.
If I got the question right, I think it's all about quality check as well. So we are scanning and sorting the plates. So talking about the new technology which is out there. So we are proving and checking the quality, sorting the plates. We have even one HGV installed, which is an autonomously driven vehicle, taking the pellets and the plates to the working position. So talking about the future, let me add that we are following up the additive welding and also robotic painting. So I believe painting is still an issue, especially in the European markets, maybe not so much in the North American market, but painting will come more and more an issue. And we are considering to do the robotic painting as well, since we know all the position where we have to go to, and we are fitting and placing and welding these parts, so the robot can easily paint these parts as well. So talking about new technology, and again, checking the quality. I mean, this is provided by our scanning and plate sorting unit, especially.
Excellent. So, go ahead.
Yeah, Doug, and the technology you're talking about, it's come down to lower levels too. You're seeing less expensive robots, even track systems now that have through-the-arc seam tracking, touch sensing capabilities. So that technology that was super expensive, 10 years ago, that was really hard to get into, is now quite affordable. It's really been leveled out, so a lot of people can use it. The newer stuff that I see coming down, you're going to see higher strength materials. We're getting into higher and higher strength steels. You're going to start seeing more automation on erection sites, not just in fabrication shops. And additive is starting to make its way into the structural market too, for things like nodes that have some strange geometric shapes to them. I always say buildings now are more pieces of art than they are actual structures.
Yeah, certainly. We've seen that on the detailing side as well. It becomes art, not just a square building. That's certainly tough. And it's one of the few things that hasn't gotten 2 and 3 times more expensive, right, over the years. It's something that's become affordable to these fabricators. So with that, again, I appreciate everybody attending. We're going to leave a little bit of time that you can go ahead and put your comments and ask some questions in the chat. We'll go ahead and let you put those in. We'll take time to review them and then go ahead and just have just some open dialogue, question and answer time. Okay, there looks like some low-hanging fruit right away. Again, I appreciate everybody attending. So where will these recordings be? You can view these on sds2.com, or we have a YouTube channel as well. So if there's people that weren't able to attend or you'd like to share it with, you can certainly direct them to those places. Some other information, and I might go to the panel with this one, but how is the welding information integrated and sent to these machines, and does Zeman or do they provide a checking of the NC1 files? How do I check what I sent is valid? So I'll leave it to you guys to do some checking stuff. Andreas?
Yeah, may I simply add, I mean, we take from SDS2 or any other software, we take the XML and NC files, and we take it on our Profit in-house software, and we check immediately all the data we get. The NC file describes the shape of the plate, the thickness, where the holes are, and the XML gives you the 3-dimensional geometrical position in the 3-dimensional room. So that means from your software, we have a beautiful interface taking all the data and digest this data, let's say, in our Profit software and send it directly to the machine. Of course, there's a chance to intervene manually if there is an approach what the software proposes you, which is not a good fit. There is a checkbox telling you red flag. Just go into the details, change a little bit the robotic approach and make the machine more happy by changing the data. But as I said, NC XML files, that's a beautiful interface with STS2.
Sure. And this is an interesting question that I think you could allude to. So by implementing some of these robotics, you've solved the bottleneck. So there was a bottleneck in my shop, and I've solved that bottleneck. Have you found on your implementations that it's just moved the bottleneck somewhere else, or is it really reducing the time of the projects?
If I might answer, I mean, coming from our assembly and weld out unit, it's definitely the welding portion. So we see in many of our installation or in many of these workshops that the bottleneck sits at the welding side. This is what we see right now, because our assembly machine is so fast and so efficient to feed at least 16 welders in one shift. So either you have these 16 welders or you invest in a standalone welding cell, but the bottleneck seems to be the welding side in the fab shops these days.
So there's a follow-up question to that, which I think makes sense. So on these implementation, do you see do the welds have to be completed by the machine, or is that what most of them are doing? Or are they maybe tack welding and sending it off to finish? What do you see as an implementation with your customers?
For the Zeman system, I definitely believe assembly is where the efficiency sits. It's where the money sits, actually. And I would say more than 2/3 of our customers, they use the assembly function and send it out to their manual welders. But having said that, that means in the third or in the second or third shift, if the assembly is already done, of course, you can use the Zeman machine to do the weld out as well. So that means the second, third shift will give you the chance to weld it out. But coming back to your question, I think most of our customers do the tack welding and then send it out to the manual welding team. Because the fitters, as we call it, or boiler makers in Australia, as they call them, that's a highly educated job. It's very hard to find really good fitters. They have to read the drawings and understand how to do complex stuff. And we actually can use them for the really top complex stuff and use them for and replace them for, let's say, the rather easier stuff to be done on the Zeman assembly station.
There's a question here about, does anyone have a machine that welds pipe railings? Do you guys offer anything like that in that world?
Assembly and welding on round tubes, let's say, we are not doing that right now, but we are working on solutions, but not yet there. So we work on any kind of beams, hot rolled sections, build-up sections. Then we have rectangle tubes, of course, hollow sections, seed channels, but unfortunately, so far, no assembly and weld out on pipes.
And I may not get this right, but one of the questions is, what is the lead time on a Zeman unit, say an SBA Conti Plus? So what's the lead time? I'm not sure if you understand that question, but
that's a very good question in these days, because unfortunately we also suffering a little bit from the supply chain disruption. But I would say these days, unfortunately, we are talking about 10 to 12 months.
Read this.
I know that Rick can add a better time to this one, but the Zeman system, unfortunately, it's like 10 to 12 months.
Yeah, and there was several comments, questions about the automated painting and actually moving into truck loading, which if for those of you who don't know, we have a truck loading tool as well. And so it can continue to, as they were talking about bottlenecks, we can continue to solve those problems down the workflow for sure.
Yeah, there are automatic painting systems already on the market, but I believe that is definitely the next step, the evolution of robotic works in your shop, that you can use the robots for robotic painting. We are not there yet, but this is definitely a future step for Zeman and Lincoln as well.
So here's a question for me. Does STS2 provide a way to optimize or maximize this equipment? For example, all my connections from welded or bolted, or something I've seen a lot of our fabricators, if they're doing a column and they want to use an automated assembly. If anything on that column gets welded, so let's say there's a stiffener or something that occurs on that column, then instead of bolting clip angles to that column, I'm going to switch everything to a shear plate. And we certainly have developed tools to allow you to change those members that once they have something welded, we'll have everything welded on it. And so there's ways to use our technology for sure to optimize the connection creation so that it takes advantage of the manufacturing of the product. So for sure, we've had to come up with ideas and tools to do that. Where in the past, normal detailing, you wouldn't have thought if one thing on the column gets welded, everything has to be in. So it's a little different way to think, but it certainly optimizes the ability to create the model correctly so it can be take the most advantage of these tools in the shop. Go ahead and see if there's any more here. And again, there was another, we kind of addressed this in there, but have you seen shop technology, people implementing this robotic impact, what design decisions? And we certainly have been in those discussions and have heard that for sure. Just trying to take the best advantage of the shop equipment so they can get bigger throughput. As we've all seen with lead times and getting projects out, that's certainly a decision that's being thought of earlier in the process for sure. Do you have any examples or videos of systems that can process large structural parts? Guys?
Yeah, of course. We have it on our homepage, on our website, www.tebau.com. And there are YouTube videos showing you the steel beam assembling units in full operation. And within the next 10 days, I believe we are shooting a very nice video showing a totally complex lineup of machines, including the Python machine, which is a beautiful setup of machines. And this will be available, I think, from 3 weeks onwards. So that means you will see then the steel beam assembly in operation, the scanning and plate sorting unit, our SPP, our steel plate patroller, which is the HGV, the autonomous driven vehicle, bringing the pellets to the steel beam assembler, and of course lined up with the Python machine, which is a beautiful single sourcing opportunity for our customers. We'll be there in 3 weeks from now.
Excellent. I'll leave a little bit more to see if there's any more questions. Will I be able to see, there's a great plug for the NASCC, so will I be able to see the Python or Zeman or any of these assembly machines in Denver at NASCC in a month?
That's not a good question, actually, Doug, because we are struggling to get the machines out to the NACC machine. No, we don't have a Zeman equipment there. Rick, please correct me from being wrong. I don't think there might be a Python machine at the booth. I've honestly no ideas. But what we have done is a 3D animated video with an online presentation of a trial run in Austria. And you can really zoom into these single machines, understanding click boxes, the features of the machine. So it's a beautiful 3D animated video, what you can use on really big flat screens on the NSCC. But unfortunately, we as Zeman have no machines there for demonstration.
Okay. Well, it looks like we've wrapped up most of the questions. Again, I appreciate everybody's time. Robotics and structural steel is something that has certainly come onto the stage, and we continue to develop and meet it. And I think it's going to continue to advance. Do you guys have any other parting comments?
No, for me, Doug, thank you very much for organizing this. It's really a pleasure to team up with you, and thanks for the good partnership here. Happy to meet a lot of customers at the NACC show. If there is any request in the meantime, please feel free to get in contact with our local distributor, PythonX, as well as Zeman directly. So thanks, by the way, for organizing that, Doug. It's really a very nice event.
Well, appreciate having all you guys on this, and the more we can educate our customers and the industry, I think the further along we'll get as an industry. So thanks again, and hope to talk to everybody soon.
Thank you very much.
Thank you, Doug.